All right, so this is basically a very cool way or a much faster, efficient way to add two complex numbers that are in, I guess this is called polar form. I think it's polar form. I think we're gonna go with that. And to keep in mind, these two have to be the same base. So if this was like 2e, whatever, this will not work. Keep that in mind for future reference. So basically, what you would probably normally do would convert it to like this a plus jb, a plus jb, then add it together and then convert it back into polar. Well, there's a different way to do it, and if you master it, which I actually haven't yet, but it would be a lot faster. So, a way to think about this is you need to split this into a way. So you'll see in a second what I'm talking about. So, um, uh, first we would probably have to find the midpoint, or we will have to find the midpoint, and you'll see what I'm talking about in a sec, what I mean, but just trust me on this. So you do 5 pi, and then you find the midpoint, then um, use your brain, which is not working right now for me, but it's 3 pi over 12, which is actually in the middle. And this has a gap of gap of 1/6. So pi over 6, pi over 6, right? Or it's also the same thing if you still can't see it. It's 2 over 12. Yeah, 2 over 12. And um yeah, so now that you find like the difference between these two, then you just um kind of like make this in this form where they have this number the same, which is the same thing as 1 over 4 pi. So you have uh this number and this number. So 5. So just put it in terms of this, is basically what I'm trying to say. There you go. So you have 5 over 12 pi, which this equals to 1 over 4 pi. And to get to this, you have to add this number, right? So plus this, right? And for the same thing for the other one, 1 over pi, you have this. But then to get from here to there, which is 1/4, you have to subtract, right? So now you have this, and you have this in these forms. Then now you just plug it in back in to up here, to this equation up here. And if you do that, you'll be able to distribute this 1/4 here because um I'm not gonna write it out because it's too much work. But basically, you put this in here, put this in here, and then you will be able to see that you can take this out. This EJ, or no, EJ to the power of 4. And then what you're left with is just these forms, right? So then you get EJ to the power of 6 plus E minus J to the power of 6, right? So hopefully you can see going from here to there to there. If you don't believe me or you can't see it, I say you just plug it in yourself and then distribute it, and it shouldn't be too bad. So now, what we're going to do from here is actually use an identity that we're supposed to know, at least in my class. Uh, Here's the identity. So cosine cosine theta equals to EJ theta plus EJ minus theta over here over 2, right? So as you can see that this this form right here looks awfully similar to something like this, right? Up here. So if we wanted to convert that, we would, if we want to convert this into something like this, right? We just move this 2 over, and this whole thing would become 2 cosine, and then this theta in this case would be pi over 6 multiplied by ej pi over 4. And hopefully that was kind of easy to follow along. And now this is your final answer, kind of. If you want to find the magnitude and the angle of this thing, right? So the magnitude is, well, the magnitude of this is 1. The reason why is because all it is just, if you draw it out, and this is the imaginary axis, the real axis, this is pi over 4, and then this magnitude is just 1, right? So it's like a definition kind of thing, like that this would always be 1, right? And then now you multiply it by 2, and then cosine pi over 6 is square root of 3 over 2, I believe. Yeah, square root of 3 over 2. And your magnitude, these two cancel out, it's just square root of 3. So that's your magnitude for these addition. And then for the angle, well, you don't really have to do any math. It's just should be just this angle right here, which is pi over 4. And yeah, that's how you do this kind of problem. It's very, very nice. If you can master it. So yeah. Ta-da. Let me end the video.